next speaker is home to many of the waterways in Portland. If you were to look at Portland on a map, you may notice that we do have a river going down the middle, but there's also a river going along the top, the Great Columbia. And in that river, you will find what some scholars call Colossal Claude. Colossal Claude has been spotted on many occasions and is described the typical way: horse-like face, 40-foot-long body, flippers, the norm, you know. And in 1963, the Shell Oil Company claims to have caught Claude on camera, a large aquatic animal covered in barnacles. So, if our next speaker seems a little bit crusty, you know why. He is Geshan Manandhar.
Your real problem is that you don't understand your problem. That's how many DevOps and continuous delivery rollouts go. So that's an issue. I am Geshan Manandhar, and today I'm going to talk about adopting a painless continuous delivery culture to add more business value. I call myself a senior software engineer, a tech provider, agile follower, and a microservice believer, because microservices cannot be good for all the teams. It depends upon how you execute it. Originally, I am from Nepal, Kathmandu, Nepal, the capital of Nepal. We are the only country which has a non-rectangular flag, to say. And currently, I am living in Dubai. That's where I traveled from. The 15-hour long flight was pretty hectic. So if I make some slip-ups, it's just because of the jet lag. OK, I've been working at Namche for the past 5 years. Namche is like the Zappos of the Middle East. Basically, we sell shoes and clothes. And yeah, it has been business for the past 5 years. We serve all the countries of the GCC, like Saudi Arabia, Bahrain, and those countries around the UAE. It's based in UAE and headquartered in Dubai. So what to expect out of this talk? This talk is basically going to be a journey of our deployments. But before that, let's have a look at what Jack Holman, the ex-GitHub employee, says about deployments. He says that your deployment should be boring, straightforward, and as stress-free as possible. Let's use my time machine and go 5 years back. 5 years back, our deployments were surely not stress-free or easy. They were cumbersome. We used to use email to send our emails to our systems team, which was in Istanbul, whereas the dev team was in Dubai. So we'd say, please deploy this particular tag or this particular branch on this particular environment. And then let's say after 5 minutes, they would come back saying, OK, everything's deployed. Do your testing now, which was pretty painful. Let's come to now. So now our deployments are very easy. It uses a chatbot. We use ChatOps. We just ask the chatbot to deploy this particular branch. In this particular environment for this particular app, deployments happen within minutes. So this talk is basically going to be about our journey from this cumbersome, difficult method to this smooth and easy deployment pipeline that we have right now. So what is continuous delivery? Martin Fowler, a visionary, said that it's a software development discipline where you build software in such a way that software can be released to production at any time. So you should be able to release your software to production at any time to your end users. That's what continuous delivery means. Another visionary, Jez Humble, who wrote the book Continuous Delivery itself, said, changes of any type should be able to go into production or to the hands of the users safely, quickly, and in a sustainable way. I say it's an ability to deploy production-ready software, your increment to your end users anytime. As soon as it becomes production-ready, you should be able to deploy it. You should not be bound to a fixed release schedule. We deploy only Monday mornings, or we deploy only when the sprint ends after 2 weeks. I think by that you're already taking some debt because something is finished. So it should reach your customers first, rather than you trying to wait and saying, OK, Monday is coming in 4 days, and then only I can deploy. That's already stopping you. So delivery process should never stop you. If it's done, if it's production ready, let it go to production. And then the next step of continuous delivery is surely continuous deployment. The only difference that we see here is the last switch, the last switch or the last step to go from your acceptance test mode to production mode is automated in continuous deployment. Amazon could do this in 2011, where it was able to deploy every 11.6 seconds. I don't think if they were doing continuous delivery or something was being done manually, they could deploy to production every 11.6 seconds. So continuous deployment is the next step. We are not doing it, but I think this is a very good thing to do in case you have very good tests, like end-to-end tests that cover the thing, and as soon as the test passes, it just goes to production, just like that. And no one is doing a switch or doing any manual process to get it to production. Wealth is created from creating value. OK, we as Namshi, we recently sold 51% of our company for $51 million to a big business house in the UAE. So basically what I'm trying to say here is we were able to create value. And that's why like the majority stake is right now with another business. So if you think of all of your work responsibilities, it just boils down to two things. You are there working either to add value to your business customers, or you are there to save cost for the business that you're working for. So value you add, or all of the work you do, basically just boils down to these two things. Whatever you do, if you have these things in your mind, you would be able to deliver things better. So let's see at how we do continuous delivery at Namshi right now. But even before that, let's see at what tech stack do we use at Namshi right now that enables us to do this continuous delivery. We have a big bandwagon, let's say, of around 100 microservices right now. And all of our servers are on AWS, which is managed by SaltStack for the configuration part of it, and Terraform to bring up the servers, like to do the setup. A small part of our backend is in PHP, and a lot of things are there right now in Node.js. We have some Python and Go somewhere here and there, but a lot of it is basically Node.js for the backend, and for the front end, we have the front-end JS frameworks, like React. We are heavy on React right now. We have some of our old apps in Angular as well. Yes, for sure. All of our apps are Dockerized, and it helps us a lot when we have to ship new changes, ship all of our incremental changes. And all of our apps are deployed with Kubernetes. Kubernetes is a great container orchestration tool that we have, backed by Google, as most of you know. And it has helped us a lot to get things like high availability, which was earlier done a lot different. And with Kubernetes, as it is a very really thought after tool, a lot of things are just taken care for you. All you need to do is get used to with its lingo and all the jargon. And after you get used to it, all you do is ship containers, schedule containers, be it Docker, be it something else like Rocket, and Kubernetes takes care of all the difficult parts. So let's look at our current deployment process. As I said, we are already using ChatOps, and we have a chatbot called Nancy, and it is a WhoBot bot. Who here uses ChatOps? OK, a lot of them. Nice. And how many of you identify yourself as software engineers and not DevOps people? OK, a good number. Nice. So basically, the software engineer or anyone who wants to deploy, because it's a chat interface, we use Slack. Someone would just go there and type a command saying, Nancy, please deploy this particular application, this particular branch or tag to this particular environment. And then Nancy, the bot, is actually responsible to run the right kube deploy command to the Kubernetes master. Then after the command is run, Kubernetes master comes back with saying this happened about your deployment. Maybe it was good, or maybe something went wrong, which is not that likely. Generally, deployments go through smoothly. And then again, the same deployment output comes back to the user as I showed in my previous slide. And for us, every change is tracked, be it any type of code, be it infrastructure code, be it application code. Every change is tracked. We do peer reviews, so everything goes through the process, and then only changes are released out. Now let's look at how it actually happens, the continuous delivery pipeline at Namshi. As soon as there is a ticket, someone picks up the ticket and then is done with the code part. It is pushed on a feature branch on GitHub, and as soon as it is pushed, all the tests run on our CI server. We are using Travis right now, and when the tests are passed, or when the tests are even running, we do a peer review for all the changes. All of it is peer reviewed. So every change is at least peer reviewed by one other engineer, maybe even more, like depending upon the complexity or how critical that particular ticket is. When that stage is done, all the changes go onto a staging environment. It is tested very well on that, and when it is production ready, as I said, we don't wait for a particular schedule, or we don't wait for everything to be fine. As long as it is deemed production by the one who did it, then there is a tag coming out of that branch as it was done in a feature branch, and then that particular tag goes into production. After that, the thing to notice there is we are very heavy on looking at our logs and checking all the resources are fine. It is being monitored well. And after one is satisfied that everything went through fine, then it's time to merge the tag back to master, and that's how our software delivery pipeline runs. So as I said, there is just one branch coming out of master. We only have one perpetual branch, which is master. We do not do the full Git flow where we have 3 perpetual branches: master, release, and development, and basically all the things that have been done come to development, then go to release, and then come to master. We used to do that, but I think we found our problems in that, and then we are now going to this simplified Git flow or GitHub flow approach, where we only have one perpetual branch. For each task, a new branch comes out of it. After it's done, a tag is taken out of it, and then it goes back to master, as you can already see it in the picture. Another thing that has helped us a lot in the past years is migrating to a REST-based JSON API. 5 years back, as I remember, there were just 2 monoliths in the whole code base. Let's call it A and B. And around 4 years back, we decided to go for a SOA, service-oriented architecture. And then we started splitting things. But even then, we gave birth to another monolith which had services inside it. So there was another problem that we had. But the good thing we decided when we did this SOA approach was we went for a REST-based JSON APIs. What it helped us now is even when we write our microservices, the contract of the API still stays the same. Let's say it was being pushed on, or like it was being given out by PHP monolithic app earlier. Now maybe it will be written completely rewritten as a Node.js app, but what the data and the format that it gives out or takes in still stays the same. So deciding on that format and deciding to have a REST-based JSON API really helped us. Even if you think of it from having a mobile app, unless you don't have a very good API, you will not be able to do a good mobile app. For example, if we were still using our 2 A and Bs, the whole monoliths, I don't think our mobile apps would be this effective. Probably we would just have been slapping on like a mobile theme on top of the website and treating it, which is not the best thing, at least in 2017. Yes, another thing that helps us ship changes faster is going to microservices. Because there are a lot of small components now, let's say even if there are four software engineers who want to work, they can work on each one independently, and no one is stepping on some other's code or some other's changes. And as they are microservices, they can just be deployed and could go along or go forward independently. You have to think about things like backwards compatibility, or let's say if there are two related microservices, you might need to go live with this one first and then this one, so that you don't have any breakages or any any downtimes. But those things you could manage easily. But let's say if it was the old one and then 2 people were doing something related, then probably you are spending half an hour just to merge your code, because it's going to surely step up. You're going to step on someone else's code, right? And yes, we have a very strong culture of central logging and monitoring. Right now, we are using Sematext for all our logs, Sematext Log Sense, which is our central logging UI for now, where we can see all the logs. Another thing I would like to add up here is we are heavy on application logs and not only server logs. So there are things like Nginx logs where you can see what happened, like 400, 300 HTTP errors came up. But if you have very good application logs saying what happened in the application itself, it always helps you. So if you are doing some form of logging now, I would really suggest to start having more logs from the application level itself saying how is the application performing. And New Relic helps us do all the monitorings like error level monitoring and other resource monitoring. If you take my word, without logging and monitoring, it's like shooting in the dark, because you just deployed something and you don't know what happened. But let's say you just deployed something and then you can see it on New Relic that your error rates are spiking up. It was hovering around 2 or 3% before deployment, and after deployment, it just grew up to 25 or 30%. That means something you deployed is surely breaking something. So you could just catch those things as per need. You could roll back or just do a hotfix on top of it. These kinds of things, logging and monitoring really, really help you a lot. Another thing that has helped us in this transformation in the recent years is we now ship containers. We now ship Docker containers than just shipping code. How does it help? If you think of it, with Docker containers, you are shipping the whole stack, the operating system, the right version of the language that you are using, and then your application on code on top of it. There is no disparity between your development environment, your staging environment, and your production environment. Whatever was running fine inside the container in your local environment is going to run the same way in any environment you put it in. So then there is no problem of it runs on my machine anymore. As long as it runs fine on your Docker container, it's going to run fine on any environment that you put it to. Yes, another thing that I was talking with one of the Scrum Masters here, she was mentioning that they do not do any form of feature flags or Cannery deployments. Feature flags basically is a check that says if this condition passes, then release this particular feature. For example, you could do a feature flag that says if it ends in @yourcompany.com, then you are able to access it. With things like these, it is a lot easier and a lot safer to deploy things in parts. So if you could hide a feature behind a feature flag and put it on production, it would be a lot easier to actually test the whole thing in production, right? So those kinds of things has helped us a lot. Another thing that we have done recently is Cannery deployments. That means if it is a critical thing, we roll out step by step. By step by step, I mean first we roll out maybe to only 1% of our customer base. We did this recently with a payment gateway provider. So we were using payment gateway provider A, and now we have payment gateway provider B. If it was being done like a big bang deployment, switching from A to B, I think it would have been almost a disaster if there was any bugs being slipped out. But as we do Cannery deployments, first week we just tried it with 1% of our customer base. And it already gave us things like, okay, we have some problems here, these things could be better, and things like that. But the next week we moved it to 5%. And the weeks after, depending upon the confidence that we have with the code as well as our payment provider, I think right now we are at 60 or 70%. So every week we just went up till we were, so probably in a month or two, we'd be fully confident with them and our code as well, and then it would be all of our customers and no more provider A. So these types of techniques are language agnostic and or framework agnostic, but they give you a lot of leverage to do your stuff a lot easier and always be on the safe side. Another good tool that we used in the past months was Go Replay. Basically, what this does is it replays your production traffic on another environment like staging. This is very good where you have read-only apps, or basically the apps that just do GET calls. We were doing this for our catalog app, and it helped us find out a lot of things like the production load. When production loads hit staging, then you know that, okay, these are the things that will come out, or these are the problems we will see when we release it to scale, when we go prime time. And other things were also coming out, like, okay, these are the edge cases that we have not really thought of till now. But when the production traffic was hitting both production and it was being replayed to staging, we could already find out a lot of problems, and we could already solve them before going to live. Another tool that has helped us along the same lines, is Magetta. This is a tool which we used, again, for the same app. And this was also used for load testing. So you could say, hit our servers with like 1,000 requests per second for the next 60 seconds. And then you would know how much load would the servers take. Because we were doing a migration from an old PHP app to a new JS app, so we were not sure how much resource would it take. We were pretty sure that it would take, let's say, like half of the resource that it was already using. But with Magetta, we could allocate the resource properly and not have like an over allocation for the resources, which is cost saving. So this basically summarizes our DevOps or site reliability engineering journey of the past 5 years. We basically did not have an in-house team, as I said. With our sys-admin team was in Istanbul, and then we were working in Dubai. But later, as you see, we did Vagrant for developers. We did infrastructure as code with SaltStack, and recently in the recent past 2 years, we have Docker for all the development. All of our apps are containerized, and all the developers use Docker in their local machine, and then we ship them out with Kubernetes. And we have centralized logging with Sematex. We have a very fancy-looking, very good Grafana dashboard for all of our apps to look at errors and all these HTTP codes and stuff like that. So after all this, how can you get started with a smooth continuous delivery pipeline? I think the first thing that you can do, as long as you have some code, maybe developers using Git with it, is start with an automated deployment tool or a script, and always target zero downtime deployment. Depending on the need, depending on the scale, it might differ, but targeting zero downtime deployment with an automated tool will always help you. It's the same thing. If it's repeatable, if it's automated, it's always easier. I don't suppose in 2017 someone is uploading files with FTP and then forgets one file, and boom, you have a unwanted situation. Right, and the same thing, as soon as you have some code base, it is always good to have some form of test. As they say, test without code is legacy code. So if you don't have tests, you are already not that confident when deploying code. And just adding some form of test will not help you on the long run. So do have some form of continuous integration, so that as soon as something is pushed, you know, or you get an instant feedback of green or red. And then you know if you want to proceed further or fix the test or add more tests. Right? After having some tests, it is a very good idea that you should start some form of logging and monitoring for the team. I mean, it's not mandatory to already buy some SaaS apps. You could use some open source things as well. But the main idea is having all of your logs at a central place and being able to monitor anytime. If you can do it in real time, that's best. But even if it has some lags, it will always help you, especially after deployments, because that's where things break. That's where things change, and like a stable system might not be responding as you want it to. Then you could follow on with infrastructure as code and a good disaster recovery system. By that, I mean like all of your infrastructure should be defined as code. If you ask why, for example, a hypothetical situation, but that could happen. Let's say that your data center catches fire. Okay, all of your servers go down. So how long will it take for you to come back? How long? Here, like how many say they can be back even if the data center catches fire within hours? 2, 3, like only 3 or 4 people, right? So disaster recovery is a big thing. So if you are able to define your infrastructure as code, you could be back in a matter of hours. For example, the last test we ran at Namshi, we were able to be back in almost 3 hours. So even if our data center catches fire right now, we'll be back online in maximum of 3 hours. Another thing that will help you is putting a configuration management tool in practice. Right now, we are using SaltStack, but there are other options as well. You could do a lot of things with it. For example, what we are doing right now is for each new application, we add a new MySQL user. And for that MySQL user, it will only have access to, let's say, database A, table B, read. Database A, table C, read and write. So when you have these kinds of very granular control over ACL, it's a lot helpful. You only give the access that you need, right? And these kinds of things, I mean, you cannot just assume that they will be fine. So when it is defined in code, when it is in Git or any version control, then you know exactly who is getting what. These kinds of things are very well handled by configuration management. And configuration management, which is generally declarative, you just declare it once, you run it, and then it just checks, is it there or not? If it's not there, I add it. If it's there, then I do nothing. So those kinds of things help you. Key takeaways, the last part. Always automate your process and track each change. What do I mean by this? OK, I remember the last time I went to our lead DevOps engineer. So I just went him to ask him to add one hook inside our Git repository. Then he didn't even open GitHub. What he did was he went to his scripts folder and ran a script for that particular GitHub project. And that added the hook that I wanted. So everything can be automated. If you are doing it twice or more than 2 times, automate it. Another thing that you could that you could take away from this talk is have small atomic deployments. Do it often. Do it as much as possible. Make deployments small. As soon as the code changes are small, the impact is small. So then it's easier to test. And even if you need to do 3 production deployments in a day, do that rather than doing a big bang deployment where you don't know, like, if another ticket is overstepping into something else. Right? As far as you can follow, do small atomic deployments, and GitHub Flow always helps in that because we only deploy 1 ticket at a time to production, and it's a lot easier to test and make sure that everything is fine. A strong culture of logging and monitoring is very important, and it will take you a long way. Because as I said, without good logging and monitoring, it's always like shooting in the dark. You deploy and then you pray that everything goes fine. But at times, it does not. So unless you have data of how, like, if my error rates went up, if my memory usage went really high after this deployment, it's not an easy task to do. Another good one is infrastructure as code and config management tools. They are lifesavers. You can take my word for it, because we were not doing any infrastructure as code. But now, as we have almost everything in Terraform, and as I said, even if the whole data center catches fire, we'll be back online in less than 3 hours. Last but not the least, things do not go right all the time. So yeah, I mean, it's not a walk in the park, as they say. So whenever things don't go fine, always track them. Have a postmortem meeting. Then you will come up with items that said, OK, we did these things that were not right. Do blameless postmortems. Don't blame anyone. Blame the process. People are not the problem. The problem is in the process. So you have to make the process better, right? And then come up with action items and then implement it. What I can remember of is while we were rolling out something with the checkout, we had an issue. And then one of the action items that came out from our postmortem discussion was we need to Dockerize that particular app. And within like 1.5 to 2 months, we were able to do it. So yeah, that's about it. Thank you for listening. Namshi is hiring. If someone wants to apply, you have the details there. And if I have time for questions, I would like to take it.
Sadly, we don't have time for questions.
Thank you. No problem.
Thank you so much.